Good morning, Geometry Honor students. So Mr. Chen again. So this one, it's the second half of section 7.1 from the Big Idea Geometry textbook. So formulas involving polygon. Objective: apply important formula to solve any polygon related problem. So record that the formula we were talking about yesterday. So the sum of angles of a polygon, so it's considered n minus 2, the quantity of n minus 2 times 180. So where n is the number of sides of a polygon. The reason why that we want to subtract 2 because we want to find out the number of triangle inside the polygon. So once we come up with that, the number of triangle inside the polygon, so we just multiply by 180 because the measure of all the angles of a triangle, it's always considered 180 degrees. So the new formula that I need to know, so this one is not covering from the textbook here. So in order to find out the number of diagonals, so let's say we do have a quadrilateral. Okay, so one of the polygon, quadrilateral. So the diagonal is that the side length from the vertex to the opposite of the vertex. Okay, so for this one quadrilateral, so as you can see that we do have two diagonal. So the one going this way, the other one going that way. Okay, so the way to find out the number of diagonal inside a polygon, it's always consider n times the quantity of n minus 3 divided by 2. So n is the number of sides, so it's a quadrilateral, so it's 4. So 4 minus 3. Okay, so for n, which is 4. So 4 times the quantity of 4 minus 3 divided by 2. So reduce, so 2 times 1, which is 2. So 2 diagonals. So let's say that we do have a pentagon, okay? So 5 sides polygon. So the number of diagonal here, so here's 1, 2, 3. Could be 4, 5. Okay, so then that'd be 5. Okay, so plug in a number, so 5 times 5 minus 3 over 2, so that's going to be 5 diagonals. Okay, so now let's look at that example. So quadrilateral, we did it already. So how many diagonals can be drawn from the following polygon? What about a triangle? So triangles, we got n minus 2 divided by 3. So 3 times 3 minus 2 over 3. So cross that out, 3, 3. So we do have 1. So just one diagonal. So that's a triangle, like that. Okay, so this one, you just find out that from the vertex to another vertex. Okay, so let's go back to this page first. Okay, so n divided by 2 times n minus 3. Not divided by 3, divided by 2, excuse me. Okay, so this one divided by 2. So as you can see that here, if that's a triangle, so 3 sides, so 3 minus 2, that's 1. 1 times 3, 3. 3 over 2. And this one looks like it doesn't make sense. So for the number of diagonals of a triangle. So it looks like this one will be none. Okay, because that from the vertex to another vertex. So triangle, then that'd be no diagonal. So for the formula here, so would that be considered invalid? Okay, so using that n times n minus 2 divided by 2. N minus 3, excuse me. So sorry about that right here. So once you subtract, so 3, 3 got canceled, so none of the diagonal involved. So 0. So quadrilateral, we did it already. Decagon, so 10. So 10 times 10 minus 3 over 2. So reduce, so we got 5. 5 times 7. Then this one would be considered 35. So 35 diagonals. So how many sides does a polygon have if the sum of the measure of its angle is 1,440? So using the formula that we were talking about yesterday, so the sum So n minus 2 times 180. So we said that 1,440 equals n minus 2 times 180. Okay, so divided by 180 and then add 2. So you want to find out the number of sides here. So 1,440 divided by 180. So let's see what that is. So using that the long division. Okay, so let's see. 7 times 8, 56. 8 times 8, 64. 8 times 1 plus 6, so it's 8. So divide it, so we got 8 equals n minus 2. So that means n equals 10. So it's a decagon. And then this one's similar, so x. No need to solve for x here, so we just want to set that equal to n minus 2 times 180. So divided by 180, so we got x minus 2 equals n minus 2. So that means n equals x. So 8 right angles, so 8 right angles. So this one, that means 8 times 90, so 720. So 720 equals n minus 2 times 180. So 720 divided by 180, then you'll get 4. So 4 equals n minus 2, so that means n equals 6. So it's a hexagon. So given trapezoid ABCD, find the measure of angle CAB, and then the measure of BDC. Okay, let's use different color here. So CAB, and then the measure of angle BDC, and also angle 2. So starting with that angle A, since we do know that this one's linear pair, so angle A, angle CAB, then that'll be considered 180 minus 45. So we just consider 135 degree. So the measure of angle CAB. So once we get this angle here, so the way to find out the other angle, BDC, so we do know that this one's a trapezoid. So the measure of all the interior angles of a trapezoid is 360. So for angle CDB or BDC, so this one, it just subtract from 360. So 360 minus the sum of 45, 100, and also the one that we just found, 135. So 135 plus 45, 180, plus 100, so then that would be 280. So 360 minus 280, then you'll get 80 degrees. So once we get that angle BDC, so we can get angle 2. Exterior angles, also linear pair, so 180 minus 80. So it's what? 100 degrees. Okay, make sure that we put in the units, degrees. Okay, so now let's see what else that we have here. So find a set of polygons in which the number of diagonal is less than the sum of the measure of the angle. Okay, interesting one. So the set of polygons. So let's use that the formula. So n times n minus 3 over 2. The way to figure out the number of diagonals. And we do know that this one is less than the sum of the measure of the angle. So it's less than n minus 2 times 180. So basically this one is kind of like a quadratic inequality. Okay, let's find out. So distribute, so what we got here, so we got n squared minus 3n over 2. It's less than 180n minus 360. So we do know that's a quadratic, so you don't want to deal with the fractions. So basically what we can do, multiply both sides by 2. So we got n squared minus 3n. It's less than 360n minus 720. So basically what I'm doing there for the inequality, so basically multiply everything by 2. Okay, multiply everything by 2 here. So the way to deal with the non-linear inequality, so that means we want to bring everything together to one side. So bring everything to the left hand side here. So we got n squared minus 3n minus 360n plus 720. So that's less than 0. So n squared minus 363n and then plus 720. So that it's less than 0. So in order to solve for n, so n is going to be considered a integer because that's the number of sides of the polygon. So what we can do here, we can factor it, okay, if this one is factorable. So 720, so you might be considering the way to break it apart. So let's put in 360 multiplied by 2. Okay, so 360 multiplied by 2. But the things that looks like it's not factorable. So the way to do it, you want to find a 0 first by using the quadratic formula. Okay, so once you get the 0, you can set up that the Sine Test to get the value of n, or perhaps, you know, doing that on the TI calculator to find the value of n. Okay, so using the quadratic formula, perhaps, so negative b plus minus square root of b squared minus 4ac over 2a. Okay, so it's a big number, so 363 plus minus 363 quantity, negative 363 quantity square minus 4 times a times 720. And then divided by 2. Okay, so let's see. So using the calculator, and then you want to type in that 363. Okay, so let's start with the plus. Okay, so square root of 363 quantity square minus 4 times 720. And then this whole thing, it's all divisible by 2. Well, it's not going to give you the exact number, so just round it up. So then that'll be 361, okay, for the positive. And then if that's a minus, so 363 minus square root of 363 quantity square, or negative 363 quantity square, which is the same as positive 363 quantity square, minus 4 times 720 divided by 2. So just round it up, so then that'll be 2. So for the minus, right here, for the minus, so for the value of n, it could be considered 2. And for the positive, so the value of n, then that would be considered 361. So once you get a 0, it's an inequality, so you want to do the Sine Test. So the Sine Test, okay, so well, n got to be either 0 or to infinity, so 2, 361. And then you want to plug in a number back to the inequality to verify that whether that's less than 0 or greater than 0. So let's say that if you plug in 1, so 1 squared minus 363 times 1, that's going to be negative. Negative 363 plus 720, that one's going to be positive. So positive, which is not considered part of the inequality, because we need to end up with something less than 0. So this one, no. In between 2 and 361, so plug in 3. So 3 squared, that's 9. And then negative 363 times 3, so that number is going to be, well, this whole thing is going to be greater than 720, but it's negative, so it's going to be negative. So this one is negative. So anything that's greater than 361, so again, the whole thing is going to be positive. So to find out the set of polygons, so this one, it could be consider anything from a triangle to what? To 361. Okay? So it could be a triangle from 3, the value of n, and it's less than 361. So this could be a triangle, it could be a quadrilateral, it could be a pentagon, it could be a hexagon, it could be any kind of polygon, all the way to the 360 size polygon. Okay, so that's the situation for the value of n. Okay, so now let's see anything else. Okay, so here's another one. Prove the midsegment. So midsegment, we talked about that for this for the previous unit. Midsegments of a trapezoid or the midsegments of a triangle. Okay, so for this one, in order to find out, this one is the midsegment. So basically we want to show that MN, it's half of the base, which is what? Half of base is AC. So what we can do here, so let's get the midpoint for M and N. So the way to get the midpoint, so this one using the midpoint formula, so 0 plus 4b divided by 2, comma, and then 0 for N, for M, also the Y value, so 0 plus 4c over 2. So 4b over 2, then we'll get 2b, 4c over 2, we'll get 2c. So this one is considered 2b, comma, 2c. And then for N, so similar, get the midpoint. So 4b plus 4a divided by 2, and then 4c plus 0 divided by 2. So what we found here, which is b, 2b plus 2a. And then this one here, just 2c. So this one is just the xy coordinate, so we just want to label the point. So 2b plus 2a, comma, 2c. And now again, this one we want to get the distance. So in order to get the distance of segment AC, so we use the distance formula, or simply just count it. But let's just plug in that to the distance formula. So x2 minus x1, so 4a minus 0, quantity squared, plus 0 minus 0, quantity squared, which is 0. So 4a quantity squared, so 16a squared, square root, so 4a. So the distance here, that's 4a for segment AC. And then for segment MN, again, using the distance formula, so square root, so 2b plus 2a minus 2b, quantity squared, plus 2c minus 2c, quantity squared. So 2b minus 2b, that's 0, so 2a quantity squared, so we do have 4a squared. 2c minus 2c cancels out, so 0 squared, which is 0. So square root of 4a squared, so we got 2a. Okay, so this one is 2a. Again, we want to show the relationship. So the segment, the midsegment, it's only half of the base. So check it out, MN, what is that? 2a, 1/2 times segment AC, which is 4a. So 1/2 times 4a, so it's 2a. So 2a equals 2a. So it's actually not that bad. It's just like a coordinate proof. Okay, find a midpoint, get the xy coordinate for those points M and N. And then once we get the midpoint, and then you want to find out the distance throughout the segments, so the midsegment and also the base, AC, and you just need to show that the relationship. Okay, so thank you for watching the video today. So I'll see you guys next time. Have a great one.